This is Chapter 9.1, Testing Claims. And what we're going to do is use some data that we've already used, and it's the number of hours 13 students spent studying for a test and their scores on that test, and they're shown at in the table below. And the question is there enough evidence to conclude that there's a significant linear correlation between the data? So you're going to look at alpha equal 0.01, and you could use the R value from the scatter plot video that I've already done, but you're going to see it again, so you'll know that that's what you're doing. Alright, what you're going to do is you're going to test the significance of the population correlation coefficient, and that's P. And the appropriate test that you'll do is that P is equal to 0, and that means there's no correlation, versus P is not equal to 0, then that would mean that's a significant correlation. So we're going to take this and take a look at it. Okay, what you're going to do on the calculator is you're going to put your X values in L1, your Y values in L2, and we're going to press stat like we have hundreds of times, and we're going to highlight test again and go down to choice E. Now it's way down in the calculator, but it's called linear regression t-test. And the reason we're doing a t-test is because your n is less than 13. Remember, if it's 30 or greater, you can use the z-test. So you're going to put L1, your hours studying, L2, your test score, and 1's going to be your frequency. On the next line, you're going to put that beta and P are equal to not equal to 0, and you're going to press enter. So let's take the calculator and take a look at this. And here are your numbers in L1 and L2. So here are my hours studying. These are the scores that the students made. So I'm going to move this calculator over so you can kind of see what I told you to do. So you're going to go to stat, over to test, and you're going to scroll way down, because once the numbers turn to 0, they start having letters. And so there's E, so I'm going to press enter, and I want my X list in L1. If it didn't say L1, I'd have to change that. I want my Y list in L2. That's correct. My frequency is 1. This is equal to, not equal to 0. I'm going to leave the next line blank, and you would have to press enter when you get here to change that. Like if I wanted to change it to here, I could press enter and it's changed. Otherwise, and now I'll have to press enter again, otherwise you're just moving with the down arrow key. So I'm going to tell it to calculate, and when I calculate, here's my T. There's my T that we are going to be interested in. That's one thing we're going to be interested in, the test statistic. We're also going to be interested in the p-value, and it's written in scientific notation. So what you have to do is move this decimal to the left 6 places. So the 7 is one of the places, and then you're going to put 5 zeros. So that's your p-value, and here's your R value. So if we go back to the calculator, you'll see each one of those. There's T, P, and if I scroll down, you're going to see the R value next. So there's your R value. So when you see an arrow, that means there's stuff above or things below, so you scroll up and down. So anyway, that's what I'm interested in. So here's what I'm going to have. When I go back, you'll see that since P, this is P, is less than 0.01, then the correct decision is to reject the null hypothesis. In other words, I'm not saying there's no correlation. I'm saying I'm rejecting that, so that means there is a correlation, and this indicates that there's a significant linear relationship. You can look at that R value and tell there's a significant linear relationship.